if we go to our slide now and we're going to see how can we use this principle, right? So we're going to use the principle of conservation of energy. Now, easiest thing to do is write down all the information that you have. We're going to use the mechanical energy at the bottom. So it's the mechanical energy of this object with the arrow at the bottom. Now remember that the mass of the arrow plus the object is 1,3 kilograms. In the previous example, we calculated that this velocity, that the arrow and the object was moving at a velocity of 3,08 meters per second. So this object is moving. Now the reference point that I have here is this line here at the bottom. So the object with reference to the line at the bottom, to the ground, is 0 meters. So there's no height. So we know that h is equal to 0 meters. When the object moves, it goes to a new height here. And also remember, when it goes right, sorry, I was just reading two questions. I am going to do another 2 examples on the same work. Okay, so just bear with me and just take it one step at a time. We will do more examples of the same problems. Right, so if you just go back to the slide, remember what is happening here is that the ball is moving. Right, so it's moving to that point there. Now at that point, at the highest point, we know that the ball is stationary. It won't go higher than that. Now we're looking at, we need to calculate the height here from the ground to the ball there. Right? That is the height that we need to calculate. All the information that we got, the mechanical energy at the top, the mass of the arrow and the object is 1,3 kilograms. The velocity of this object at the highest point is 0 meters per second, and we need to calculate the height. So there are 3 things that we have: the mass, the velocity, and the height. The same at the bottom, we've got the mass, the velocity, and the height. Now, how do we approach this problem? So we're going to start with the principle of mechanical energy. Now remember that the principle of mechanical energy is that your mechanical energy, your E mechanical, at the bottom, at the lowest point, will be equal to E mechanical at the top. That is conservation of mechanical energy. So simply your mechanical energy is conserved. The mechanical energy at the bottom is equal to the mechanical energy at the top. Or you could even say that the mechanical energy at the bottom is equal to the mechanical energy at any other point. So another question there is, why won't the object go higher? Right, just remember that when something swings, it's going to swing to its highest point, and once it's at the highest point, it's going to come back. Okay, just take your pen, and as it swings, it's going to go that side, it's going to stop, and then it's going to come back. The object goes to its highest point, and once it's at the highest point, it needs to come back. And at the highest point, the object stops. And what we want to calculate is, what is the height, what is the highest point that it will reach when it swings to that point. Okay, I hope I make that clear. So your mechanical energy, remember there are 2 things about mechanical, just 2 energies involved in mechanical energy. It's your potential energy, which I'm going to use U, I said, plus your kinetic energy. So your potential energy plus your kinetic energy at the bottom is equal to your potential energy plus your kinetic energy at the top. Now, we said at the beginning that gravitational potential energy is mass times g times h, right? Mass times gravitational acceleration times h. We know that kinetic energy is half mv squared. And remember that this whole section here is still at the bottom. The gravitational potential energy at the top is still, gravitational potential energy is always mgh, and the kinetic energy is always half mv squared. And this is going to be at the top, so we're going to use the information at the top. Now, when you go back to your initial problem, you now need to just simply substitute. I'm leaving bottom here so that I know that the information I'm going to use is what happens at the bottom. So if you just go back to our slide, what is the information that we have here at the bottom? We've got the mass, we've got the velocity, and we've got the height. So the mass of the object is 1,3. The velocity of the object is 3,08. And the height of the object is 0. So going back to our equation that we've written down, we're going to substitute mass of the object, 1,3. Remember, gravitational acceleration is a constant and it's 9,8. And the height of the object is 0. Now already we know anything multiplied by 0 is 0. Plus a half times the mass of the object, which is 1,3, times the velocity of the object, which we said was 3,08, right? And that's all there at the bottom. That mechanical energy at the bottom is equal to the mechanical energy at the top. The mass of the ball is 1,3. Sorry, the mass of the arrow and the object is 1,3. G is a constant, 9,8. And it's the height that we need to calculate, so multiply by h. Plus a half. Mass is still 1,3. And we know that the velocity at the highest point, it stops at the highest point. Okay, it's stationary, we said. So stationary means it stops at the highest point. And the velocity at the highest point is 0. So it's 0 squared, and we know anything multiplied by 0 will be 0. Right, so if you use your calculators, 1,3 times 9,8 times 0 will give you 0. Okay, anything multiplied by 0 is 0. Please, a common mistake that many students make is that the velocity is squared. So please don't forget to square it there. So we've got 0,5 or half times 1,3 times 3,08, and remember it's squared. And that will give you 61,6616. Right, we'll just double check there. All right, if you have a different answer, please let me know. And that will be equal to 1,3 times 9,8. And that will give you 12,74. Plus a half times 1,3 times 0 squared will give you 0. sorry, I did make a mistake. That's 6,16616. Remember this 3,08 we got in the previous question of 3.9.1. Right, so now we have to calculate. Remember we've got 1,3 times 9,8 times h plus naught. So to get rid of the 12,74, remember naught plus anything stays 6,166. We're going to divide both sides by 12,74. So we've got 6,16616. I'm not rounding off, just to make sure that my answer is more accurate. Divide both sides by 12,74, and that will be equal to h. So h is your 6,16616 divided by 12,74, and your height will be 0,48, and now we round off to 2 decimal places, and it's 0,48 meters. Right, your answer here I said is 6,16616. Okay, so it's just 6,16616. Right, so that will give us the height to where the object is going to go. And remember what principle we've used here? Conservation of mechanical energy.